Hello, everyone. My name is Nishi Ajmera. I work as a solutions architect in Publicis Sapient. And here I am to talk about AI agents, which is being hyped all around. A little bit about myself. I'm also a woman in tech ambassador. I'm passionate about promoting diversity in the world of tech. Uh, Passionate about AI, especially Gen AI. I've been doing a lot of talks on LLMs, Gen AI agents. And here I am again with yet another talk on building AI agents for smarter workflows. So I'll get right into it. This is what we are going to cover today. I'll go through a very basic understanding of what AI agents are, how they work, and then how do you build an effective agent, how do you design an effective agent, what are the common mistakes to avoid, and then I'll talk briefly about agentic workflows and the real world applications and challenges. So before starting on what are AI agents, I just want to understand how many people here understand how the agents work. Okay. Nice. Cool. All right. So what are AI agents? So AI agents are autonomous or semi-autonomous software systems that can perceive their environment and make decisions, or they can take actions to achieve a specific goal without continuous human intervention. So these agents basically use LLMs. So LLMs are the brains for these agents, and they use these LLMs to do the critical thinking, reasoning, decision making, and then there are a bunch of tools provided to these agents, and based on the reasoning, these agents will figure out the tools which they can use to perform a particular task, right? So these are the basic components of an agent. The first one being LLM. LLM is like the brain for your agent. It is going to help with the reasoning and the planning for a particular task. Then the second important component for an agent is a prompt. Prompt is where you define the goal of an agent. Like, for example, I'll take a classic example of a travel agent, right? So if you're building a travel agent, the goal for your travel agent could be that you are a travel agent, you are here to build itineraries for the location provided by the user, something around those lines, right? So you provide the goal in your prompt. Then you also provide the instructions of how do you want to process, like how do you want to perform those texts, those tasks, and how do you respond, what kind of output do you want to provide to the user back. So those specific instructions you provided in the prompt. I'll get into the details of it in the next slide. Then the next component is your tools. Tools is basically a way for LLMs to connect with the external world. So your tools can be connectivity to your databases, your services, internet, and all those things. Then comes your memory. So now your memory can be a short-term memory or a long-term memory. So short-term memory here would be the conversation which you're having with the agent. For example, like going back to the example of your travel agent, I go to the travel agent and I say, can you find me an itinerary for a 3-day trip to Marseille in, let's say, mid of May? Now my travel agent comes back and asks me for specific days, like the dates to plan my trip or the itinerary. Then I give the dates. The travel agent goes and figures out the flights, the hotels, and day by day itinerary for my trip. And then it comes back with the plan to me. And then there are clarifying questions like, okay, do you prefer window seat, aisle seat, what kind of flight booking do you want, economy, business class, all those things, right? So there's a conversation going on with the agent, and then you're telling your preferences to the agent. So all of that is happening in one particular chat session, and that is your short-term memory. Now you can save these preferences into a database. That would be a long-term memory. So next time when you come back to this agent, the agent knows your preferences. And you can use these long-term memory to make the experience more personalized. So that's a bit about memory. And the last thing is knowledge. Knowledge is any external information which you want to provide to your agent to help it make better decisions to perform a particular task. All right, moving on, how do you build effective agents, right? So the first point here is follow the role, goal, backstory framework. So this framework is defined by Crew AI. These best practices, I have taken it from Crew AI. Crew AI is a framework which you can use to build agentic applications, agents and agentic applications. But this applies to any other framework, like regardless of the framework which you are using, you should keep these practices in mind. So going back to the role, goal, backstory framework, giving a clear goal to your agent is very important. So I'll take an example. You see an example over here of building a researcher agent. Now, if I just give the role as researcher and the goal as find information, that is not very clear for your agent. You have to be very clear in defining the role and the goal. So instead of giving the role as researcher, you give the role as that you are an academic research specialist in emerging technologies, and then you define a proper goal, that the goal for that agent is to discover and synthesize cutting edge research, identify key trends, methodologies, and finding while evaluating the quality and reliability of sources. So like you have to be very specific in your goal, right? And backstory is what gives context to that agent, right? So again, taking this example of the researcher, you can give it a backstory that you have knowledge of computer science, you have worked with research teams at prestigious universities, and your approach is very methodical, and you always cross-reference information. So when you set such kind of context, the output which gets generated from the agent is much more effective than just giving very generic descriptions in your role or the goal which you're defining for an agent. Then going back to the second rule is following the 80-20 rule, right? So the 80-20 rule over here is, so you should, your 80% of the focus should be for defining the task of an agent, and 20% focus should be on defining the agents. So this is specific to Crew AI because Crew AI gives you a framework of, like, you define the agent, where you define the role, goal, and backstory of the agent, and then you define the tasks for the agent, right? So what are tasks? Tasks focus on what to do and how to do. So if I go back to my researcher agent, one way of giving the task would be that, you have to research market trends, analyze the data, create a visualization. Now, these are 3 different actions. So instead of giving that into one task, you break it down into 3 different tasks, right? So you create one research task and you give the description that you have to research the top 5 market trends in AI and then respond it in a markdown list format. Then you define a second task, which is your analysis task. You tell the agent that you need to analyze the identified trends, and then you respond it in a structured format. And then the third task is that whatever analysis is there, you need to take that analysis and you have to create a visual representation. So make sure that your task descriptions are really to the point and you create task for one action. Don't combine multiple actions in a single task. Then the other thing is specialist over generalist. So make sure that your agents are not generic enough. Make your agents very specific. Like the example which we saw about the researcher, you have to make it specific, like you are a researcher for emerging technologies, like you're a researcher in IT or emerging technologies, right? So make sure that your agents are specific. Then the next thing is you need to have a balancing specialization and versatility. So again, this relates to the previous point. Whenever you are creating an agent, make sure that that agent has some specialized skill which can be applied across multiple contexts, and avoid overly narrow definitions, like ensure that your agents can handle variations within domains of expertise. And one more thing to keep in mind over here is consider the collaborative context, right? So your agents can be collaborating with multiple agents to perform a complex task. So make sure that you design agents that complement with other agents when they work with them. So moving on, what are the common mistakes to avoid? I think a lot of it I have covered, so I'll just brush through this. One is make sure that your instructions are very clear, because that is very important for the performance of the agent. Got tasks that try to do too much, avoid doing that. Avoid having like one task for one action. Then make sure that your descriptions align with the output which you're trying to achieve. Then make sure that you understand the process yourself for the agent before you're designing the agent. Understand what steps you would need to perform to accomplish a certain task. Then premature use of hierarchical structures. This is more around like building a crew of agents for different tasks. So instead of jumping directly in building complex agentic applications, start with a simple agent and then see how your application evolves. And then the last point is vague and generic agentic definitions. I think it's clear that you have to be very specific in defining the goals of the agents. Then, so designing an agent, there are 3 things which you should keep in mind while designing an agent. First thing is, you don't need to build agents for everything. If there is a very deterministic use case which you have, which can already be performed without using an agent, don't just use agent for the sake of it. Keep it simple. Start small. So test with a sample task. Create a simple agent with 1 or 2 tasks in it. Analyze the output of that agent, and then figure out which component needs modification. If the output is not to the point, then figure out whether do you need to modify the prompt. So prompt in this case would be a role, goal, backstory. Do you need to do modifications in that area? Or do you need to give more tools to your agent? Or do you want to modify the task descriptions? So look at those components individually, refine those, and then test it. So that whole thing goes into an iteration until your agent is performing as you expect. Right. So all of this was about one agent. Now consider the scenario where you make all of these agents work together in collaboration. And that is what makes an agentic workflow. A very common example of agentic workflow is the coding agents, which every day a new coding agent comes today. So all these coding agents are basically following this agentic workflow. I'll quickly talk about what are agentic workflows, and then we'll see how these coding agents work, or how these agents work in collaboration with each other. So what are agentic workflows? Actually, we'll talk about a normal workflow. So what is a normal workflow? A normal workflow is a set of defined steps which has a sequence of execution defined, right? Now, that's a normal workflow, non-AI. Then coming on to the AI workflows. Now, your AI workflows can be agentic and non-agentic. So a non-agentic AI workflow is where you have a LLM into your workflow, and your LLM is performing a simple task, like you're using an LLM to summarize a paragraph into, summarizing it into a few points. So that is your non-agentic AI workflow. Then coming to the agentic workflow. So in the agentic workflow, we use the components of the agents, like planning, tool use, reflection. So if you see over here, user entered a query. Now your agent is figuring out a plan to execute that query. So for going back to your researcher agent example, right? It will figure out, okay, I need to do research on this topic. These are like my steps. So it will make a plan, and then that plan will be passed to the tool use. So tool use will take the plan and then figure out what tools I can use to perform those steps. It will then collate the response and send it to the reflection agent. The reflection agent will take the user's query and the output and figure out whether the output is relevant to the user's query or not. If it is not relevant, if it needs further details, it will send it back to the planning agent and it will ask it to modify the plan to make the output more better. And this loop goes in. So this is an iterative loop until your result, the desired result is achieved. So that is your agentic workflow. So what makes a workflow agentic is 3 steps. One is you need to have some sort of planning step into it. Then you execute those plans with the tools, and then you reflect and you iterate. Some common real-world use cases, one of them is coding agents like Windsurf, Cursor, or Claude. Claude also released a Claude code, and then OpenAI has also released a new coding agent. So like there are a lot of coding agents coming into picture. Now how these coding agents work? So in this coding agent you will have multiple agents, right? One would be analyzing the requirement, then second agent will be using that requirement, building the code. Then there would be a testing agent which would be writing test cases, would be executing your code and checking whether the desired results, whether your code performs as per the specifications which are mentioned. So that's one of the example. A lot of workflows are being built in the customer service automation. Like there are a lot of automations happening in the call centers, where people are building these agentic RAG workflows, where they are using the information which are like the company specific information which are used to respond to users' query. Those are being used by these agents to automate the customer support workflows. Then you have workflows being built in financial analysis and reporting and supply chain optimization. Now, looking at the challenges and limitations of agentic workflow. The first challenge is it adds unnecessary complexity for simple tasks. So like AI agents can add overhead when used for straightforward workflows like form entry or basic data extraction, and cases where deterministic rule-based automation is sufficient. Introducing agents can lead to inefficiencies and possibly reduce the performance. Right. Then another thing is it reduces reliability as a result of increased autonomy. Because your agents are probabilistic in nature, it introduces unpredictability. It makes your output less reliable and harder to control, and that's where you need to implement guardrails into your applications, into your agentic workflows, and you need to make sure that there's always a human in the loop in all these workflows whenever you're starting to build these agentic workflows. Then the third point is ethical and practical considerations. So not all decisions should be delegated to the AI systems. When you're starting to build, as I said before, you need to have humans in the loop for critical decision making or high stake wherever there are high stake areas involved. I think that is it. If there are any questions. So yeah, okay. Thank you.